Hi, my name is Walker Reed, and this is my Physics 2 Lab 1 charged tape. So the purpose of this lab was to test the amount of charge that a piece of charged Scotch tape would have. In this lab, we suspended a piece of tape across two textbooks and took another piece of charged tape and held it up under it until the tape started to repel and measured the distance at which the tape started to repel. Here's the picture of our experiment setup. Principles used in this lab include Newton's second law, which F is equal to ma, the gravitational force, which is F is equal to negative mg, and Coulomb's law, which has a picture to better represent it, the K constant obviously being the 9e to the 9 times q1, q2, and then over d or r squared. For an overview of the lab and some possible sources of error. So the tape was found to have a charge about 9.36 e to the negative 9, and we also calculated that there was about 1.524 e to the 9 atoms on the tape. The electron per atom ratio then was about 38.39. Some possible sources of error include that it's possible that the tape could have lost some electrons due to being handled when completing the experiment. It's possible that they could have moved on and tried to neutralize. And it is also possible that when handling the tapes, one of the pieces of tape could have had a different charge than the other one when they were assumed to be equal. So for the experimental model, which was kind of described already, but the tape was suspended from the books, and then we brought the tape from underneath, and then we are assuming that air resistance is negligible, and that tape B is a point charge, obviously, and then we also are assuming that each piece of tape has the same amount of charge. So for an experimental overview, the length of our tape that we used that was suspended was 0.1524 meters, which meant that the mass was 0.1524 grams, and when multiplied to the negative 9.8, we got a force of gravity of 0.00149 newtons acting on the piece of tape. When you use because the force of electricity and gravity must be equal when the tape starts to repel, we set that equal to the electric force, and that's how we calculated the total charge of 9.358 e to the negative 9. Using that, the formula that they give us in the instructions, we found there to be around 58 billion electrons, which led to the 38.39 electrons per atom figure. After that, I wrote some code to model the experiment. As you see, I have all my constants at the top with the weight, the charge, force of gravity, and how far the distance that we calculated for when it separates was. From there, I generated a sphere to represent each piece of tape, calculated the force of gravity, then the electric force, and then from there made the arrows that include each force going up and down, which you can see are the same magnitude there. So the first question was, what if electrons had positive charge and electrons had negative charge? Because both pieces of tape would still have the same exact charge, the actual results of the calculations would be the exact same. For example, if they were both negatively charged, they would repel, and even if they were both positively charged, they would still both repel. So that wouldn't change anything at all. Why is it important to handle the tape as little as possible? As mentioned previously, if you touch the tape too much and your hand doesn't have a charge, the charged tape may start to neutralize and lose some of its electrons, causing the experiment to not be as effective as if it had all of the electrons for when it originally got charged.